actually in a barn. This month, actually, we're celebrating 30 years as a limited company in the UK. 1996, June 5th to be exact, we were officially sanctioned as a UK limited company by Mr. Gary Edwards, who was one of the co-founders of Deben, which originally started as Deben Research. So we started making tensile stages for SEMs back in the mid-90s. Fast forward to the mid-2000s, we started manufacturing tensile and compression stages for CT systems and have a product that's pretty well known in the market called the CT5000. We do some other things for SEM as well. We've had a very popular product called the Cool Stage for temperature control. That technology has also been ported over to CT systems to be able to control simple temperature sample. And moving into 2025, 2026, we've got some pretty new and exciting stuff that we're doing to kind of help people understand more about their material in CT. So you'll see this is our product portfolio as it exists today. Effectively yesterday, it's now got a new member, and we'll talk about that in a second. Those are some of the flavors of the CT5000 that we offer. So it's tensile and compression, either at room temperature or temperature control from -20 Celsius to +160 Celsius, or heating, which is room temperature to up to 250 Celsius. And then you see the temperature control stages, which do some combination of heating, cooling, and also heating as well. We also offered a 500 Newton stage, which was great for small, really sensitive samples. And then our heavy hitter, which I'll talk about more, is our open frame system. So what's new? We introduced yesterday at dXCT the new generation of CT5000, and it's an improvement based on feedback from users across the CT community to make it more effective for high resolution imaging. You can get it closer to your source. It also has some improvements for tensile sample loading, which if you had thin samples, it could be a bit of a struggle because there were only 2 support screws. And now we've added a third, so you get a kind of a tripod effect, so it's very stable for loading tensile samples, especially if they're small and thin. We introduced a modular design, right? I talked before about 3 different flavors. One of the things that we've done now with that modular design is basically you can have all 3 of those flavors in one unit, and it's customer exchangeable. So you don't need a service person, it doesn't need to come back to the factory. You can have all 3 different capabilities all in one system. So if you think about a multi-user facility, cost of ownership, that sort of thing, that's kind of where we geared that towards. I know it sounds counterintuitive to a company to not want to, sell more systems and make money, but at the end of the day, we're only successful if we're enabling research and being able to do things like cost of ownership make a huge difference. Greater accuracy, Deben Test Suite, which is our new software, flexible platform. Again, you get a lot of capability in one system instead of several. Lower cost of ownership, as I mentioned, and that high resolution performance. So what, right? It's all about results at the end of the day. This is a little snippet from our website where it uses a tool called BIOS to collect all the academic research papers that cite Deben products. So if you go to our website, deben.co.uk/publications, you can find and look at research that's been done using our instrumentation, CT5000, CT500, open frame, all that sort of stuff. Here's an example of a paper that was produced looking at void growth in aluminum, and they were doing tensile samples with the CT5000 tech. Really, really fascinating because even though Deben makes great product, really where the rubber meets the road is what customers are able to do with it. Another example of some tensile samples that had some inlaid continuous fiber that was reinforced in those tensile samples. And again, in the CT system, what they were able to do was when they were conducting those tensile experiments, they could see where delamination was starting to occur. And you can see where that circle and then those red arrows kind of annotate that. This is another paper from a very good colleague and friend of ours. His name is, why did it just escape? He's from ETHZ in Switzerland, and he uses a EasyTome XL from RX Solutions and our open frame system to do wedge splitting tests of concrete. So he takes sections of concrete. We did these custom designed jaws for him, and basically they can study how concrete fractures based on different formulations. He designed this test, asked us to design these wedge jaws for him, and basically get it all set up so that he can learn more about concrete in situ and in a large cabinet CT system. So we've kind of previously marketed this system towards synchrotron and beamline applications, which it's great for, but it also is suitable for large cabinet industrial CT systems, provided that there's room. And if the stage doesn't support the weight, we've also designed custom mounting platforms to sit over the stage to be able to facilitate it and have a handling system to get it in and out of the cabinet so that it's not there all the time. It's pretty heavy, it's about 115 kilos, so not easy. You certainly wouldn't want to go in and try and lift it out. So now I want to talk to you about something that's really interesting. It's not even a product for it yet. It's a concept, and this is geared more towards the non-destructive testing side of things. We've had a couple of customers that have brought challenges to us where they didn't want to take things apart, they didn't want to crush things, they didn't want to pull things apart, and they wanted to still do CT evaluation. I can't go into details of who the customers are, and if I even tried to hint at it, NDAs would be violated, dogs and cats would be living together, it would be pure pandemonium. So, but basically what this does is it provides an environmental chamber effectively for a CT system. So if you had, say, a PCB and you were having issues with information passing through a data connector and you suspected a problem there, because that PCB is operating in a high temperature environment, say 120 Celsius, you could take a look at that and see what's happening in real time inside of there. You can do gas flow in and out. You can change the window material. We typically have been using aluminum in these prototypes that we've been working on, and it's scalable, right? You can see there's 5 frames. What that allows you to do is if you've got smaller samples, you can use 1 or 2 frames plus the covers, 3 frames, whatever you need, and still get nice and close distance to the source so you get high resolution. You're not sacrificing that because you're in a big chamber. So really interesting stuff, and it leads to some of the bleeding edge stuff that's happening, and what we've kind of uncovered in some of the discussions that we've had with these customers who are in industry is they've known about Deben for a long time, but they've never really understood how their samples could potentially benefit from using various in situ techniques. And that's what we're all about. We're all about enabling in situ research. So with that, I'll conclude. Anybody have any questions?